Hello and welcome to taik18. I'm Mohammed Adnan, and in this video we are going to discuss about how to use Apache Spark in Microsoft Fabric and what is Apache Spark as well. So we are talking a lot about Spark in our previous videos, right? Yeah, stay tuned for that and we'll discuss in deeper in today's video. Before to that, if you are new to this channel or if you haven't subscribed yet, just click on the subscribe button and also press the bell icon to get the latest notifications. Now let's get started. So Apache Spark is an open source parallel processing framework where it's designed for a large scale data processing and analytics. It has a multi-language processing where you can use Java, Scala, PySpark, or Spark SQL for that, and it's fully managed in Microsoft Fabric. So we're going to talk in more detail about that, how and what we are going to use that. So prepare to use Apache Microsoft Spark. So if you look into this Power BI workspace and if you go to the workspace settings, there you will see this option about data engineering and science in the Spark compute. Each workspace is assigned to a Spark cluster and workspace admin can manage settings for a Spark cluster in that workspace setting. So specific configuration settings include node family, runtime version, and Spark properties. We can define everything onto that screen. So the people, those who are working on the Spark, and if you're going to adopt that in Fabric, they can familiar with these things and they can configure the things whatever they need onto their processing here. And here, Spark open source ecosystem includes wide selection of code libraries for common and sometimes very specialized tasks, since a great deal of Spark processing is performed using PySpark. So the huge rank of Python libraries ensure that whatever task you need to perform, there's probably a library for your help. So the Spark open source ecosystem includes wide variety of selection of code libraries, and library management is performed at the workspace level. So you have another option in that settings, library management, where you can include any libraries if you want to add up here. By default, Spark cluster in Microsoft Fabric include many of the mostly common used libraries. But if you need any install other libraries, you can also do library setting management in the workspace settings here. That's beautiful, right? You can also add, there's no limitation for that. Even if you want to have a specific customization, you can also make use of that. To edit and run Spark code in Fabric, you can use Spark Notebook or you can use Spark job definitions. So you have two different options, Notebook and job definitions here. So this user interface, which you see it here, interactive environment for coding and collaborative node, where you can write your code, connect to your lakehouse, and then you can process your data. When you want to use Spark to explore and analyze data interactively, you can use Notebook. Notebook enables you to combine text, images, and code written in multiple languages to create interactive artifacts that you can share with other collaborators. The beauty of the Spark definition is like you can use 1 or 2 cells in Python, another 3 cells in SQL, PySpark, SQL. It can work on that. So there is a beauty on that. So Notebook consists of 1 or more cells. You can create multiple cells, each of which contains markdown formatted content and executable code. And you can run the code interactively on the notebook and see the results immediately onto this interface itself. And the next option, which we have it here, non-interactive script run on Spark at a scheduled time here. So if you want to use Spark to ingest and transform data as a part of automated process, you can define a Spark job to run a script on demand and based on a schedule. To configure that Spark job, create a Spark job definition in your workspace and specify the script it should run. You can also specify a reference file, for example, a Python code file containing definition of functions that use in your script and reference to a specific lakehouse containing data that are script processes. So you can make use of that also. So in the demo which we are going to use, we are going to demo on the first one, which is the Spark Notebook usage on that. So load data into a Spark data frame. So that's a beautiful thing. We can load our data into data frame, which I usually call this as a kind of temporary table or view of TT in SQL language. So you can see it here on this one. If you want to have a CSV file and want to load it into a data frame, you can create a code on the notebook. It will automatically add a /PySpark, which is kind of Python Spark. And then df is refers to here as a data frame is equal to spark.read.load from the location of your file. You can drag and drop from the lakehouse to that one. It's going to capture the location automatically of the CSV file. And then come on, you need to define what is that, if it is a CSV or Excel file or text, you can define it here. Here it is CSV. And then if you have a header on that, then you can mention a true for that. So that's the beauty of that. So this is the kind of infra schema where you have a structure and you are loading that structure directly and then creating a data frame for that. The next one here is the explicit schema, where we have a file, but you want to define the each and every column name, and then you want to define also the data type of that. Then you can define a schema. Like here you can see it on the screen, we have a product schema equal to structure type, and then you can define the column structure field, the field name, and the data type of that for each and every column. And then you need to define that here spark.load that read in a data frame, and this has to be schema, product schema, which are referring up here into data frame here. This is also possible. You can also make use of that. So transform data in a data frame, how you can do that. So use select to create a new data frame from individual column. So previous example, we have seen everything to load into that data frame. But if you want to pick up anything specific from that data frame into another data frame, where you can define it here. So here in this case, we have a price list underscore df equal to df, which is the previous data frame dot select. And then we can define here product ID and list price. Only these two columns I need from this data frame and loading into another data frame here. So you can also use filter conditions where clause. We are defining it here on the below one, bikes underscore df equal to df dot select product name, category, and list price, and close the bracket and then dot where the df, which is the data frame of previous one, and then category is equal to mountain bikes. So we are just applying a filter statement here where it's going to filter only category mountain bikes and select the column product name, category, and list price out of it. This is similar itself. It's not a kind of complex starting up here. The basic thing, whatever you want to do, the transformation is looks similar itself. But if you want to do complex thing, then we'll go a little bit deeper on that. So if you want to summarize a group by with aggregated function, you can also use that. We are same using df.select the column, product ID, and category, and then group by category.count. So it is going to give you the list of category product ID inside one category here. So demo everything we are going to talk about that in this previous in the next video itself, but we'll just cover the basics of the theoretical concepts here. So if you want to write back to the data frame, what you can use that. So df.write. So previously we have seen only read, right? So here we are using the write.mode equal to override. So you want to override any existing data, then you can use that. And which format you want to override. So you want to override the Parquet format, and this is where the location and name of the file here, which you mentioned here. And use partition to split the data into distributed files. So this is actually a great part where we are going to split the data by year, for example, and write mode to be override in a delta Parquet file format. The usage of that is, you can see it on the image, we have data for 2020 separate, 21 separate. So if you have a big volume of data and you want to split the data into different year in order to get the data from easily from each and every folder partition, then it will be a good option for you. You can store the data into different partitions, and then you can get your data only for a specific thing here. And work with data using Spark SQL, my favorite. So save a data frame as a meta store object. So use the meta store to define tables and views as well. So save a data frame as a view in the meta store. So df.create or replace temp view from this product view table. And then you can also save a data frame as a new table in a meta store. So df.write to format delta.save as a table of product. You can also make use of that in order to read and write from that one. So create external table. So create external table, df.write delta, save as table, and then path where you want to define that. So we are going to cover those things in the demo as well. So work with data Spark using SQL. So you can also want to query data using Spark SQL API. You can also make use of that, and this is really amazing thing. So we can define our SQL query itself here in order to read or write the data here. You can see if you want to add a new line, you can also use the slash to generate a new line for that. And both of you can see the example here. You can use Spark API directly. It's actually running the Spark SQL query inside the Spark Python, which is the Spark.SQL. But the below one we are using up here directly the Spark SQL itself, so that we are directly writing a SQL script here. And also you can see we have a percentage SQL, which means the particular cell is actually SQL Python, Spark SQL itself. So how you want to visualize the data here? So everything we can visualize using the notebook chart. We can use matplotlib on that, and also we have other libraries where you can make use of that in order to visualize our data here. This is all about using Spark theoretically in Microsoft Fabric, but now we are going to look into that in demo as a real project. So before that, if you are new to this channel or if you haven't subscribed yet, just click on subscribe button and also press the bell icon to get the latest notifications. See you in the demo. All right, so this is another part of the video, which I'm going to show you the demo here. Analyze data with Apache Spark. So this is the second part. So Apache Spark is an open source engine for distributed data processing, and it's widely used to explore, process, and analyze huge volume of data in data lake storage. Apache Spark is available as a processing option in many data platform products, including Azure HDInsight, Azure Databricks, Azure Synapse Analytics, and Microsoft Fabric. One of the benefits of Spark is support for a wide range of programming languages, including Java, Scala, Python, and SQL, making Spark a very flexible solution for data processing workloads, including data cleansing and manipulation, statistical analysis, and machine learning, and data analytics and visualization. So there are many things we can use there. If you're kind of like me, that you are not from data engineering kind of background, I am actually from application development to reporting, and then from SQL and from here to reporting side. So if you are like me, then you still don't need to worry about that. If you are familiar with SQL, then you can make use of PySQL in that case in order to generate this kind of stuff. But still, learning Python is the good option I can say, because PySpark here in this one is the versatile language, the Python, where you can make use of not only here, you can also use on any other applications, many other applications here. So in this one, we are going to talk about this using this demo sequence itself. I'll just go through one by one step, so you don't need to worry about how these things work. It will just at least give you a glimpse of information about how this actually works. All right, so moving on. So let's go to my workspace here, which is Fabric Lab 02, and here let's create a folder, which should be Lab 02 here. Usually we need to create a folder, and then we need to create a lakehouse. From that, we can extract all those information. Either we can use our existing lakehouse, or we can create another lakehouse. It's up to us. But for this demo purpose, I'm creating specific lakehouse for these things. So here I can create a lakehouse on this, and then I'm on top of that. So create a lakehouse here, and then let's give it a name, which should be lakehouse underscore lab 02 and then 01, and create here. As simple as that, like we have seen in the previous example. This will open up my lakehouse here, and now I need to upload some dummy files here. So in the file section, let's create a new subfolder, which I'd like to give it a name here as orders, and click on create. So there is a folder available for me, so I'll just copy that and then click on files and then upload. I can also upload folders and files. So in this case, let's upload a folder because we have seen how to upload files in previous session. So this is the one L2 orders, and click on upload. So this will upload all files from L2 orders to this only if you trust the site. Yeah, upload it here, overwrite and upload. So this is going to upload 3 files of 2019, 20, and 21, and it's done. All right, so if I come back here and click on refresh on the file section and click on orders here, now I should see 3 files here. And the L2 orders, so it has taken a separate folder here itself. So you can upload the folder here. That's the reason. So if you want to move from here, if you click on the 3 icons, it is not option to move here. So in that case, let's delete this one, and then you can create upload files directly here. All right, upload files, and then click on this location. So these are the 3 files, and open, upload here. All right, done. So if I click on refresh now on the files area, and again click on the orders one, so I can be able to see the information of 3 files here. That's it. Now the next thing here is we need to convert these into tables one by one, or you can use Apache Spark Notebook in order to do all this kind of stuff. So on the top here, you can see we have open notebook option. Click on that, and then you can use existing notebook, or you can create a new notebook here. For now, I'm going to create a new notebook here, and then it's going to be seamless experience. But actually, I'm going to use existing notebook itself. But I'm going to show you how we can do this process. So clicking on the new notebook here. So for this, I get to give the name as dummy one. But by default, it's going to create automatically the notebook on. You can also see the notebook one it has added here. If you want to rename that, you just need to click on the top left and that small down arrow, and then you can rename it here. That's it. All right, on the left hand side, you can see we have Explorer, and here we can add data sources here, resources and lakehouse. So if you click on this lakehouse, then you can add a lakehouse. By default, as we have created this notebook from the lakehouse itself, it automatically has link to this notebook lakehouse here. And this is Explorer 1, and on the center, you can see the canvas. If you want to collapse this one, you can collapse and work on this notebook here. So you can add any kind of languages here. If I click on this one, I can see on the top, on the right side, we have different languages here. So PySpark, which is Python back, Scala, .NET, Spark C#, Spark SQL, and Spark R also here. So you can make use of any of these languages to transform the data and visualize the data here. All right, this is how you can create a notebook in a lakehouse. Now, if I go back to my previous example, which I already opened up here, and this is actually covered the topics which I want to cover here on this video, because I need to copy and paste each and every code, it will take much more time. So I have already copied all the code here, so we can go through this one by one here. So sales order data exploration here. So right now this is connected to this lakehouse, which is coming up on lakehouse BP600 Spark 01. And here these are the codes here. So we can create a cell. We call this as part of cell here. So we can create the cell and we can initiate the process one by one from here. So if I run this one, for the first time itself, it's going to take a bit time because you need to start the engine and compute resource, everything behind the scene. So it will take a bit time in order to start that. And then it will just run everything fast here itself. As you can see at the bottom of my screen, it is showing up running cell 2. So it will move on. How many cells do I have it here? It will run one by one. Okay, first of all, what I'm doing up here is from pyspark.sql.types import star. So actually, I'm importing the required libraries from pyspark.sql types here. So we need to have a libraries here like we usually do in every programming languages so that we can create things here. And then I'm actually creating a schema here as we imported the 3 CSV file. So first of all, we need to create a schema of the table, and then only we can read and write it into the table, right? So if you go to this one, we'll discuss on the error why it is so. No issues on that. So here, this is a schema which is showing up here. Let me reduce this one by collapsing these options, and then you can see we have complete view of this notebook. So here we have a schema of the structure, but we can see it here: sales order number, which is string; sales order line number, which is integer here; order date is a date type. Similar kind of thing, we can add any number of columns here based on our requirement. And then we need to use df, which is actually called as data frame. This is the kind of view, temporary view we can create in SQL, right? So similar kind of thing like CTE, what we have covered on my SQL challenge as well. Similar to that, it is going to have a temporary storage. So it is actually giving the same structure here. So data frame, spark.read format, CSV, and then schema. And then this is order schema, which is the name we have given for this one. And that load files orders start.csv. So whatever we have this CSV file inside to these files and folders on the lakehouse, it's going to load based on the schema, and it will read it the CSV file and store it into a data frame. And finally, is going to display this view, which is the data frame, and display and bracket the data frame is going to show us the information here. Now you can see it's giving me the result, how this looks like. So this script is actually reading the files and showing up the result using a data frame. That's it. And the next one, what we have it here, customer DF with data frame. So customer, we are just extracting the customer name and email where we have a roadside on this one. So data frame is actually, we are referring to the previous slide. As I said, it's going to be a temporary view. So we can use this same data frame throughout our demo sessions here. So from this actually extracting only the select customer name, email, where data frame that item is equal to wrote these things here. Just an example how we can query these things here. And you can see the language which is showing up here is PySpark itself. And print that customer count and print that distinct count, and also display the customer distinct here. So you can see this showing up here 133. This is the distinct customer name for this query, where we have applied the select, and also we applied the where condition here. So we have a distinct count is also 133, and display the customer distinct. So we are showing up here customer name and email for that filtration here. Cool. And after that, if you scroll down, we can also add another thing, which is product sales, which is actually, this is going to be another data frame for us. And now similarly, if we go to this one, the customer is also another data frame for us. All right, so DF is the base, and from that we're extracting all the other data frames for here. So product, which is showing up a variable data frame is showing up. You can see this message here, variable product sales data frame. So selecting this item and quantity, group by item and sum here. So here the result is this item, we have this much of quantity based on their 3 CSV files. All right, that's cool. So from PySpark.SQL functions and import. So we are importing all the SQL functions from these libraries and using this here on the top of that one. So when you're copying these things from this learn document from here, sometimes it will add a space in front of that. So you need to make sure that you are removing the following spaces if it is there in the before of your statement. If it is a space there, then you will get an error because of that space. So here we are using another view here, which is a data frame, yearly sales. So df.select, which is a year, I'm converting that the order date into year, alias I'm giving the name here to be year, and then group by year. And for that, I'm using the count and order by year here. So that's the value showing up here. And if you display on this one, what is doing the result here? So we are getting the value of year and the total count of orders on this particular date, the transaction which is happening on that particular year. That's cool. So these are some of the things where we can make use of PySpark in order to get the information what we need. So again, we are importing this PySpark SQL functions and create year and month column. So we are using a transform df, another data frame. So with column year equal to year, and with column month, which is a month, we are using the function here. So we are converting the order date into year and month and using that inside to this data frame here. And then create the new first name and last name fields. So we are adding a 2 different columns, and here also we are adding a 2 different new column, which is the first name and last name. So df dot and transform df dot with column. So it's actually overwriting the same data frame here. So with column means it's going to add additional columns here. So this is the name of the column, and we are splitting the customer name with the help of split function, and column, which is the customer name, comma. If you have any space, then it's going to take split that customer name, and I'm going to take this first area of that name as a first name, and then the similar thing which is going to add here, and it's going to be one, which is the second part of this text. It has to be the last name here. Similarly, we are using the filter option here, and the next step, transform df sales order number, sales order line number, order date and year, month, and then first name, last name, email, item, quantity, unit, base, times. These are the columns which we are taking up here, and we are reordering the column here and display the first five itself. So far we have seen every record. So in order to avoid this one, you can also use display and then view and then dot limit bracket 5. If you do so, then it's going to display only the top 5 records from here. So here you can see it's showing up top 5 records, and year column added, month column added, first name, last name, and email, and other also is added here. And within the sequence how we have defined in the previous step here. All right. So after that, we need to create another cell. So actually we have, once we mouse over here, we are getting a code and markdown. So code is nothing but it's a cell which is showing up here. Markdown is nothing but if you want to type any headings on that. So for example, this actually step what it does. So transform df dot write dot mode override parquet this files slash orders. So it is actually reading that into a file which is the transform data of orders in the parquet file format onto the lakehouse. So override files. I'm just giving that here. Override is existing one. And then if I click on any blank space, then it's going to add a text on top of this one. It's just to differentiate that on this particular notebook. So this is going to return that the transform data saved. That's what the print message we have option that. So after running this one, it's going to transform and save the data. If I look back here on this one, and then you can see the new folder added here as a transform data, which we have mentioned on the notebook. And if I click on this one, then it's going to show me the available thing. But if I just expand this one, here also we have option about it's just giving me orders. Okay, so in the next step, even though it's not showing up here because of this, we are in the notebook view. So that's the reason. But the next step, what we are written here, orders.df, which is spark.read format, parquet that load from this folder. It's the same application, it's the same location which we are using up here, file transform slash orders. And here we have written up this from the view which we are transformed in the previous step, and now we are using up another data frame in order to read that information from the table and display at the bottom here. So now you can see this is the output of that from that file folder. All right, that's cool. So here after that, what we are using up here, orders.df.write partition by year, month, mode, order wise, parquet on the partition data. So first of all, what we have done, we have just taken up these 3 files and transformed few of the columns and added few of the steps and loaded into a different folder. And then we are reading up into a different data frame. From that data frame, we are splitting up the data, and then we are storing that information into a different folder as a parquet file itself. And after that, when we read this one as a year filter here, you can also see year filter, then it's going to get only the data for that particular year. That's pretty amazing, right? If you expand this partition data, now you can see we have a year wise information here. But if you look into this one, so orders.df and write partition by previous step, what we have seen here is orders.df.write itself. If I expand this one, transform data.write mode override parquet, and this is the folder. But here, if I scroll down, then we have used here write.partition by, and then mode is equal to override parquet, everything is fine. So write dot partition by is an additional thing. So we are partitioning based on year and month column, and it's going to create separate folders for that and storing that information. This is really helpful if you have a huge amount of data and you want to split this data, partition the data based on year, you can make use of this information here. That's pretty amazing. That's how powerful it has done very fast itself. Compared to all the engines which I worked also during my Fabric experience, then we have a data flow Gen 2, we also have a pipeline, we also have a notebook to get the data and transform the data kind of thing. Then I feel like Spark Notebook has most advantage in order to speed up our process. All right, so we have this information about showing up for 2021 year. That's pretty amazing. And after that, what we have? So we need to write that format delta that save as a table on this one. So df, which we have at the earlier state, so write that format delta table, save table, and save to. So I already have this one information, so I'm just giving here at the sales order 4. So that's why it is giving up the error here. So table is already available, so how you can overwrite that? All right, so from here we can click on this one. Either we can click on run particular cell, we're clicking on this one, or else if we click on this down arrow, we have other options: run all above this cell, or run this cell and below, run selected code itself. So I just want to run and this below everything. So as we already the run gene is running, so you can see the running cell is going on one by one. So while this is loading, what actually it does? So it is just writing this into a table, and we are getting the SQL table information into this result here. So spark.sql describe extended sales order 4 dot show truncate equal to false. So it says going to give me the result of this one, which is this table name and the data type, and then null or not null kind of thing. It's a kind of detailed information about that tables. That's beautiful. And then we are using Spark SQL. Now here comes my best part. So we have a data frame now, and then Spark.sql select star from this is the lake house, and this is the name of the what is the table name. So the DBO, which is the schema, actually is not working for now, but it will work in future. And limiting this to be 1000 record, and then showing up here the data from result here, and this is the result. So we can query the information of the lakehouse either using Spark, or you can Spark Python, PySpark, or you can also use this language about Spark.sql, and you can create a SQL statement for here. Just beautiful. Or else, if you are familiar with SQL itself, then you can just change the connection from here at the bottom from PySpark Python to Spark SQL. Then you will get an option about double percentage and SQL. It means this code particular thing is going to run based on the SQL. Even though on the top you can see the PySpark Python is basically the name of the language of the entire notebook. But for this particular cell, this is going to run the Spark SQL. That's cool. So select year, order year, and then sum of unit price into quantity plus tax as gross revenue from sales order and this one. And now you can see group by order by year, this is gross revenue showing up on the result. That's pretty amazing. And if I can use the same statement, select star from sales orders, it's going to load me all the information of the sales order. So we are seeing about using the Python, and we are also seeing about how we can use SQL query here. So even now you can see we are using the Python Spark here. Spark Python. So we can type a variable here and then write our SQL statement. So if you want to add a new line, just you need to add a slash here. So select cast year, and then which is a year, converting the order date into year, and then using the same logic, unit price, quantity plus tax, gross revenue. It's actually the same query which we have seen previous cell, and then using that as a kind of Spark query, and then show up here. So this basically we can either directly run that query, or also we can also use data frame in order to get that information into that and view the result here. So both of them are working fine. Now it's a part of visualizing the data. So for that we have certain amazing libraries. So one of them is matplotlib, import by plot as plot here. So we are importing all the libraries from these things, and then we need to use the df sales and the df spark to Panda. So DS Spark is the one which we have created here. Order and gross revenue. These are the three values we are going to visualize in our graph here. So two pandas is a data frame, requires a pandas data frame, not a Spark one. So matplotlib works on the pandas data frame, not on the Spark data frame. So that's the reason you need to convert this into the root pandas. So it will now convert into pandas data frame here. So create a bar plot of revenue by year. So plot.bar, which is we are going to use that from this library. That bar graph, and x-axis to be DF sales order a year and height to be DF sales and gross revenue. So we're referring the column, what is the x-axis and what should be the y-axis. So here height is the y-axis here, and display that plot.show is going to show us the result here at the bottom, which you can see 2019, 2021, and this is the value showing up here. So similarly, we can get another cell and importing the libraries here, and we need to clear the plot area where it is already available because we are using the continuous option here. And again, create a bar plot for revenue by year. This showing up here the same one which we have used previously, but here this time we are referring here color to be orange here. And still we can customize the chart. The title we need here revenue by year, X label to be year, Y label to be revenue, and the grid has to be this color. This has to be the line style, and the line width axis equal to Y, and alpha 0.7, and the tick marks equal to 45 degree rotation. So this is what is showing up here, the information. And here the 45 degree rotation which is showing up here, and orange color and the line tick is also available here. We can customize similar things, and we can also make use of other chart types here, which is on this one. But now I just want to cover you one more thing, which is actually showing up here, the another chart. So we have seen about the bar chart and the pie chart. We can use yearly count, df sales, order year dot value count, and here axis dot pie. So ax1 dot pie, and the title is equal to orders per year, and the legend equal to years count dot keys here. You can pause the video and then just check out this code to understand how these things work, and the result actually showing up here like this. We have a graph bar and also the pie chart on this one. The last one which is showing up here over this demo is use a cPann, because matplotlib feels like we had to use multiple things in order to get the result. So multiple people have worked together and has created few applications, few libraries. So cPann is one of them based out of the matplotlib. It is much easier using when compared to matplotlib. So import cPann as SNS, and then we are clearing the plot area. And then axis, we are using up here same the bar chart, x-axis and y-axis, and data to be df sales, from where we need to pick the data, what should be the x-axis, what should be the y-axis. This is much clearer about when compared to the previous one. So plot.show is showing up this information, which is showing up here, 2019, 20, and 21 in different colors. That's pretty amazing. And similar code which we have it here, which you are using, the theme is white grid, and others information are all same. And this is the result which shows up here. So this is how we can make use of Spark Notebook. Even if you are not familiar with the language of Python Spark, then you can learn about that. But if you are getting started with that, then you can make use of this tutorial as a basic to start your journey, because it covers many of the things, the transformation, partition, extract and reading and writing the information. Everything is covered on this basic course here. So I hope you got much clear information about how you can make use of Spark SQL and make use of your SQL knowledge inside to this itself here. So if you like this video, just hit the big thumbs up button. If you're new to this channel, or if you haven't subscribed yet, just hit the subscribe button, and also press the bell icon to get the latest notification. But make sure you turn on the notification on your devices, sharing with your friends and colleagues. If you have any queries and feedback, let me know in the comment section below. Thanks for watching. Keep learning. See you in the next video.